So the first thing we're going to do, if you get out your ion chart on that yellow periodic table, I want to talk about some of the things that are going on here. And then we'll be continuing the notes from the other day, which should already be in Notability. All right, so when you take a look at the ion chart here, what I want you to notice is that you have some elements, like barium here, with a +2 charge. And we know that also from looking at the periodic table. Barium is in column 2, and so it gets a +2 charge. Barium always gets a +2 charge, never has any other charge, just +2. Now, if we scroll down here, what you should notice is that we've got things like cobalt, and there's 2 different ions for cobalt. Cobalt with a +2 charge, and cobalt with a +3 charge. So the one with a +2 charge we call cobalt 2, and the one with a +3 charge we call cobalt 3. Now, these particular types of ions are metals, they're cations, and several different metals can have more than one possible charge. And so we're going to talk about what we do with these special metals. Pretty much everything that we've learned about formula writing and naming is going to be the same. There's just going to be a couple of little twists that we have to do to distinguish compounds that have different ions. So that's what we're going to talk about today. All right, so continuing on in our notes in Notability, these are called multivalent. Multivalent is just a fancy word for elements that have more than one charge. In this class, we're going to be looking at metals. In fact, most of these multivalent elements are transition metals. So they're in that middle part of the periodic table. And so our naming and formula writing, the basic idea isn't going to change, but there's a couple of special things we have to do when our compound has one of these multivalent metals. One thing that has to happen is that the name has to include a Roman numeral in order to specify which form of the ion is in the compound. So for example, here's part of the problem. If I have copper chloride, copper can have a +1 charge, in which case copper chloride is CuCl. It can have a +2 charge, in which case it's CuCl2. Those are both copper chloride, but they're different compounds because the copper has different charges. They actually are different colors. They have some different properties.
Wait, but wouldn't copper have the... Never mind. Isn't chlorine?
So, if you see the Roman numeral in a name, what that is telling you is the charge on the metal, the charge of the metal. And most of these that we're going to use this year are actually on your ion sheet. So you can sort of look on your ion sheet and see which ones have Roman numerals after them. That means that there's more than one possible charge. And the word we use for that is multivalent. So here's our first example, and we're given the name, iron 2 fluoride. What this 2 means, this is the Roman numeral 2, it means that the charge on the iron is +2. Okay, so this is iron with a +2 charge. So it's iron 2 fluoride. We know fluoride is in column 17, so it has a -1 charge.
Yeah.
So then when we write our formula, we need to make sure that our charges cancel. So we need 1 iron and 2 fluorine. So this is our formula for iron 2 fluoride.
So 1 iron, 2. I don't know why it wouldn't be.
So this 2 is telling me what this charge is. So if I had iron 3 fluoride, this isn't in your notes, but just to compare, that would mean that iron has a +3 charge. And it would have a different formula,
so
right?
So it would be 3 fluorines. So it would be FeF3.
F3. Oh.
Right, right. So the first one is iron 2 fluoride. The second one is iron 3 fluoride.
Ah.
All right. So this next example is cobalt 4 sulfide.
What if it was just the 1?
IV is 4.
What if it was just 1? Like, is it a 1 plus or is it just?
So this is cobalt 4 sulfide. That means that cobalt has a +4 charge. Sulfide we can figure out because it is in column 16. It's got a -2 charge. So just like before, we're going to figure out what combination of the ions is going to cancel out the charges. So I need 1 cobalt and 2 sulfides.
Need 1 cobalt?
Yeah, it's the same charge.
What, no?
Yes, it does.
All right, so now what we're going to do is we're going to go to naming. And so formula writing isn't too bad because you have the name, it's got a Roman numeral in it. The Roman numeral tells you the charge of the metal. And so then you just write the formula the way you normally would. When you name these types of compounds, the name has to have a Roman numeral. And in order to figure out what the Roman numeral is, you have to sort of work backwards. So we have to break it apart into its original ions. So if I have this compound, Hg3P2, I want to figure out what ions this came from. Remembering that the overall charge for a compound is 0, my charges have to cancel. So phosphorus, because it is in column 15, has a -3 charge. Mercury, if you look on your ion chart, has more than one possible charge. Mercury can have a +1 charge, and it can have a +2 charge. So the question is, which one is in this compound?
+2.
Okay, so if we say +2,
Well, it has it too.
okay, so we have to think, are the charges going to cancel? Yes. We've got 3, because if we've got 3 mercuries and 2 phosphoruses, it's going to add up to be 0. So they do cancel out. So mercury has a +2 charge. And so the name of this compound is going to be mercury 2 phosphide, because mercury has a +2 charge. That Roman numeral tells me the charge of the mercury. All right, here's example 4. We're going to do another naming. So remember, when we have a compound that has one of these multivalent metals, or a metal from the middle part of the periodic table, the name has to have a Roman numeral in it. And the way we figure out what the Roman numeral is we work backwards from the formula. So this is manganese chloride. We need to figure out what the charge on the manganese is. So manganese chloride has a -1 charge. And notice that so manganese has a +3 charge. And the name of this is manganese 3 chloride.
Got it.
So, okay, I get it. So,
Okay.
Okay.
So here's example 5. Again, we're looking for the Roman numeral, so we have to work backwards.
So it would be AU. So nitrogen's 1 and
So there's one nitride ion with a negative 3 charge,
copper.
and there's 3, this is gold.
Oh yeah, sorry.
There's 3 gold
Plus 3.
ions. So what is the charge on each gold ion?
One,
On each gold,
one.
positive 1. Yeah.
Positive 1, right.
Because
Yeah, because you've got 3 of them to cancel out one of the nitrogens. True. And so the name of this compound is gold 1 nitride.
Okay.
You getting it?
Slowly.
Slowly.
Just like everything.
All right, so now what we're going to do is we're going to throw in a polyatomic ion.
Oh no.
Okay, so here is FeCrO4.
Iron, chromium.
Okay,
oxide.
now wait a minute. This has 3 element symbols in it, and we said that when you have 3 or more element symbols, there is a polyatomic ion. So we're going to look at it and say, does it start with NH4? Because that's the only polyatomic ion that would come at the front of the formula. It doesn't start with NH4, so my polyatomic ion must be this ion, which is called chromate.
Chromate?
Chromate.
I was going to say chromium oxide.
Yeah, that's what I'm
Well, if it was a compound, it would be, but this is an ion, and they are on your ion chart. So CrO4 is chromate. And when we look that up, we get that CrO4 has a negative 2 charge. So we have 1 CrO4. Okay, we only have 1 of those in our compound, and we have 1 iron. So the question is, what does the charge on my iron have to be? It's going to cancel out the charge on the chromate.
Oh,
2.
2. Yeah.
Plus 2. Good. So it's going to have to be plus 2. So the name of this compound is iron 2 chromate.
Iron 2 chromate.
Okay.
I got you.
All right. Okay. Okay, so here's another one with a polyatomic in it. SO4 is called sulfate, right?
We're going to need a positive 2 with it.
Yeah.
So each sulfate has a negative 2 charge.
So each of them needs a positive 2.
So there are 2 sulfates in this particular compound because of this subscript here.
She has to have 4.
So the charge on the cobalt has to be positive 4 to cancel out all the negatives.
Wait, but that has no excellent.
Man, it's so easy, man.
So this is cobalt 4 sulfate.
Why wouldn't this be plus 2 for all of them? Because that's basically
Because it is.
All right. Last one. So this is NiC2O42. C2O4 is called oxalate. We've got 2 oxalates. We've got 1 nickel. And the charge on the nickel has to be
2.
okay, so if I have a plus 2 on the nickel, if I have plus 2 on the nickel and minus 2 on the C2O4, what is my formula going to look like?
NiC2O4. Correct?
Right.
Okay.
Is that what we have up here?
No.
No, it doesn't match. So nickel doesn't have a plus 2 charge.
So it would have to be plus 4.
It's going to have to be plus 4.
wanted
Oh,
start focusing.
dang it.
Okay, so nickel, this has got to be nickel 4 oxalate.
This kid cares about freaking chemistry.
Okay,
That actually makes more sense.
So if you look on Canvas, under the Unit 4 module, there is a page with answer keys, and I have answer keys posted up through worksheet 4 so you can check how you're doing. The assignment today is worksheets 5 and 6, so this is naming and formula writing with multivalent metals.